All right, hey Josh. Hope that you're feeling better. I am finally getting there. I'm going to return to work Monday. So I wanted to go over the quiz that you're going to be taking on Monday. So basically we're looking at a lot of unit rate. Okay, so how much does one thing cost so that we can figure out how many 2 things cost and 3 things cost and 4 things cost. So basically that's going to be your bottom line here, is understanding how I can go from 1's cost to 2's cost, and then creating some equations in order to do that. So we are looking at number 1, and you did this correctly. Very good. Both sides are completely correct. So it said the tour operators thought it would be a good idea to get a souvenir t-shirt for each customer who went on the ocean bike tour. They found a company who sold the t-shirts with their logo for $6.25 each. Okay, $6.25 each being the most important part here, because $6.25 each tells me already that one shirt costs $6.25, right? And that's how you're going to start your table. So it asks you to make a table and a graph to show the shirts and their cost. So number of shirts, perfect, and cost, perfect. You did this amazingly. Okay, so here is your table. So one shirt costs $6.25, 2 shirts cost $12.50, right? Because we know that one costs $6.25, all of these numbers are going to be multiplied by what it cost for one shirt. So I'm sitting here putting times $6.25. Okay, so that tells you how you got that number. Also, what's important with table and graphs is that you understand this is the X and this is the Y, right? Because if I'm going to graph a table, I need to make sure that I'm doing that correctly. So here, you know, your graph still looks right, even though you got it backwards. Okay, so X should be the number of shirts. This should be the number of shirts. And the Y should be the cost. So it ends up being the same here, and your graph is correct. But on the test or the quiz, I want you to have this is the X and this is the Y. So X is the number of shirts and Y is the cost. Your graph's going to look extremely similar when you flip them, but she'll probably take off points for you having the Y at the X and the X at the Y. Okay, and that's the whole reason behind the table converting to the graph. So on B, it asks us to write an equation that shows how to determine the t-shirt cost for any number of customers. Any number, right? So any number tells me that's something I don't know yet. So that's going to be my variable, right? What do I know? I know that the shirt cost $6.25, right? And what else do I need to know? How many shirts, right? They said any number, so I'm going to use a variable there, right? I'm going to use the variable, let's use T for t-shirt. Okay, so I'm sorry, I first made an N and then now it looks terrible. All right, so T for t-shirt, and that's going to be what my cost is equal to. So that's it. That's all that they're looking for, is for you to show you understand how you came up with the X and Y in your table, right? So you were told one shirt is $6.25. Well, then 2 times $6.25 is $12.50. 3 times $6.25 is $18.75, right? So that's what the formula or the equation is going to look like. I know that $6.25 is for 1. T is my unknown. Whatever number I put from that table here is going to give me my cost. This is exactly what you did here. You said, okay, $6.25 times 2, put the 2 in for the T, equals your cost, $12.50. So you're just creating an equation for the work that you've already done. So don't let that intimidate you, okay, buddy? How many shirts did the company buy if their total cost is $100? All right, so I'm going to use the same formula, right? And I'm going to say that that's $6.25 times how many shirts did they buy? How many shirts? We don't know. T is equal to what? They told us what the cost was. They told us the cost was $100, right? So we have $6.25 times how many t-shirts equals $100. Okay, so you know how to do the algebra here, right? I'm just rewriting it smaller there. In order for me to get t by itself, that's always my goal, to get my variable by itself, I'm going to divide by $6.25 on each side, right? So then t is going to be equal to 100 divided by $6.25. I've got to move that decimal, right? 1, 2. I can't divide by a decimal. Here's that decimal, move 2 and add those zeros. Okay, so 625 can't go into 1, it can't go into 10, it can't go into 100, but it can go into 1,000. Right? I'm just doing the math here, buddy. Oop, look at me. I lined up wrong. Sorry, bug. 625. Okay, I'm borrowing all the way across. That's a 9, that's a 9, that's a 10. You're really good at that, so you should be fine there. 10 minus 5 is 5. 9 minus 2 is 7. 9 minus 6 is 3. Okay, that is less than 625, so I did choose 1 correctly. And I'm going to bring down that last 0. All right, so I'm looking at 6 can go into 37 how many times? 6 times 6 is 36, so that helps me to estimate what that's going to be. So I'm going to try 6 here. 6 times 5 is 30. 6 times 2 is 12, 13, 14, 15. And 6 times 6 is 36, and 1 is 3750. All right, so that's our answer. T is equal to 16. You can check yourself by then going back and saying, is 6.25 times 16 equal to $100? And that answer is going to be yes, because we did proper division over there. Okay. Now, the same thing is going to just repeat for the next couple of questions. Okay. We'll just have to understand what the equation is. What am I looking for, and what is given to me? Okay, we're always wanting to see what's given to us in order to plug that in. So the equation D equals 45 times T represents the distance in miles traveled after driving a rate of 45 miles per hour for T hours. Okay, make a table that shows the distance traveled according to this equation for every half an hour between 0 and 4 hours, right? So that's going to look like, let's go long ways with it because we don't have a lot of room, right? And we're going to do an X and a Y, which is going to be our mile. Let's do, wait, what we got to do here? Hours and miles, right? So what did we know for sure? We knew that we got to get to 4 hours. We got to make us a bunch of little spots here. All right. So I'm just setting it up right now, right? So we want to start with 1/2 an hour, 1 hour, 1.5 hours, 2 hours, 2.5 hours, 3 hours, 3.5 hours, 4 hours. Why did I do that? I did that because it said every half an hour. 0.5 is a half. 1 is a whole, 1 hour, 1.5, 1.5, 2. I've added 30 minutes to each one, right? So what was given to me was that 44 miles each hour per hour. So I can fill in 44 right there. Okay. What's half of 44, dude? Half of 44, 22. Correct? So that is an easy one, right? So now I'm going to use a formula that's going to help me figure out what each one of these is. What is that formula? Hey, here it is. Distance equals 44 times T. Okay? So I'm going to say 44 times 1.5. 44 times 1.5 is going to give us 66. 44 times 2, 88. 44 times 25, 110. 44 times 3, 132. And so on and so on. 154 and 176. So what's happening here is that if I'm going up every half an hour, do I have to sit here and say 2.5 times 44? No, I don't. I can add 22 every half an hour, right? So it's 22, it's 44, it's 66. 66 plus 22 is 88. 88 plus 22 is 110, right? Because I knew those first two and could get those pretty easily, then I could complete the chart, okay? Don't make it more complicated than it needs to be. I don't need to be sitting here going, oh gosh, 1.5 times 44, 2 times 44. I can look and find the pattern and complete that chart. Now, if I want to go back and check one, make sure that I was right, I'm going to try 3.5 hours times 44. Okay. And I come up with 154. So I just checked myself to make sure I was doing that right. Not a bad idea to do. Okay, sketch a graph that shows the distance. Not a lot of room on this paper, but let's see. I'm going to put us a little graph right here. All right. Okay. And actually, I don't want to do that kind of graph, bud. Sorry. We're going to go with this way. All right. We're going to go with the X and a Y that way. Okay, my time is going to be X, and my distance or my miles is going to be Y, right? My time. And I'm just going to say 0.5, 1, 1.5, 2, 2.5, 3, 3.5, and 4. Make that a little bit longer, right? And then in my miles, I'm going to start at 22, 44, 66, 88, etc. And all I'm doing is a half a mile is 22. I'm sorry, half an hour is 22 miles. 1 hour, 44 miles. 1.5 hours, 66, and so on. Your graph's going to look like that, increasing, okay? All right, so if T was equal to 2.5, what is D? Okay, we're still on that same formula, right? Same formula. So we're doing D equals 44 times 2.5. We're just plugging in 2.5 for T and solving. 44 times 2.5. It's 20 and 22, 8 and 8. Okay, move that decimal once, and it's 110. Which we can go back over here and check, and that is correct. Okay, 2.5 times 44. All right. Let's see. If D equals 66, then what is time? So we're just doing a little different now. We're going to give in D, and we're solving for T. So 66 equals 44 times T. Okay. 66 equals 44 times T. And I'm going to divide both sides by 44 because on algebra, I need to get T by itself. I need to get rid of 44. The opposite of multiplication is division. So I'm going to divide both sides by 44. And 66 divided by 44 is going to give you 1.5. So is that right? At 1.5, do I go 66? 1.5, 66. This is all making sure that your graph was correct. So, the final question, does it make sense to connect the points on this graph with line segments? Yes or no, and why, or why and why not? Well, I'm going to say it does, okay? It does because if we connect these dots and we're showing a constant increase and we're showing that the rate is the same. My graph doesn't look like this. My graph doesn't look like I'm going down, right? My graph is showing me that I am continuing on a constant speed. So we're going to go with yes, it does make sense, okay, to connect points because it's showing us a constant rate of movement, which makes all of the things we just did correct. All right, number 3. Oh, wait, that one was the answer key. All right, number 3. Mark opens his bank account with $20. That's important. He opens it with $20. That means he starts with $20. And each week he plans to put $5 in it. Okay? Make a table to show the total amount of money Mark has in his bank account. And then show the amount he has from 0 to 10 weeks. So we're going to start here. And we're going to say X and Y. And we're going to say weeks and money, right? Weeks and dollar or money in account, whichever word you want to use. So we know that at 0 weeks, okay, when he hadn't even opened his account yet, he had $20. That's our given information. Okay? And we want to know all the way through week 10. I didn't give myself enough room. Sorry. All right. So all the way down to week 10. And all the other information that we have is that each week he plans to put in $5. If I'm putting in $5, I'm adding. I'm putting it in there. It's becoming an addition to my original 20. So on the first week he had 20 and then he added 5. So he's got $25. On week 2, he had 25. He added. Now he has 30. 35. Each week he's adding $5. Oopsies, $5. Okay? I hope that makes sense. 65 and 70. Okay, so all I did here was add $5 every week. We started with 20 and we added $5 every week because that's what was given information to us. I didn't have to go solve for that or find that. All I did was have to add. Okay, and now if I graph that, remember my X is my weeks, so we're gonna go weeks here, and my Y is my money, so we're gonna go Y on that money line. And we're just going to go, all right, we've got 0 here at the origin. And we've got 1 week, 2 weeks, 3 weeks, 4, 5, 6, 7, 8, 9, and 10. 10 weeks. And then our money goes from 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, and 70, right? So week 1, week 0, I have $20. Sorry, right before I start, correct? So I'm on the origin. Week 1, I have 25. In week 2, I have 30. Week 3, 35. Week 4, 40. Week 5, 45. Okay, and we're going to keep on going until we have week 10 at $70. Okay? Remember again, it's super important, X and Y. Okay, now it says write an equation to represent the total money Mark has in his account over time. So what did we do here? We had the original plus 5. The original then plus 5. Okay, so for whatever week we had. So we're going to say Y, because it's an equation of a line, okay, is equal to, what did he start with? He started with $20. Then he added $5 each week. The word each means for us to multiply in this situation. So each week he added $5. Well, if I wanted to know how much he made in 5 weeks, I would multiply times 5 right here. If it was 10 weeks, I'd multiply times 10. But it just says in his account over time. So that's an unknown. So that's where we're going to use a variable. We'll use W for week. Okay. So does that make sense? He started with $20 and he added $5 for however many weeks. So anything that we plug into this W is going to give us what we received on our chart or higher, right? So if I put 10 right here, just going to do it for example. I want to know how much money does he have after 10 weeks. Y is equal to, he started with 20 and he put in $5 for 10 weeks straight. 20 plus 5 times 10 is 50. Y equals 70. Okay, if you wanted to put 20 weeks, you wanted to put 1 week, 2 weeks, 100 weeks, right? Whatever week you're looking for, you're plugging in for that unknown right there. Now it's asking us, in which week did Mark have a total of $60? Well, if I want to know his total, that goes in the Y spot, right? So $60, he put in 20, and each week he put in 5. Which week was